Hello, and welcome to your Week 3 Lesson 2 video. We're going to look at file name expansion and quoting special characters. And some of this I'm actually going to give you a preview of some stuff we're going to learn later in the semester when we look at the quoting special characters section. But all kinds of useful stuff, and I didn't notice this again, so ignore anywhere you see assignment 1 in here. Ignore that. I'm going to have to clean that up after the fact. So file name expansion can be extremely useful, usually in conjunction with the ls command. Because if you're trying to list the contents of a bunch of files, or files with names of a particular length or matching a particular pattern, issuing, the example here, ls a.text, b.text, c.text, and so on and so forth, means that you have to know all the directories or all the files in that directory. And you might not know all the files that are in that current directory, and you may only want to see certain output. So we can use some special characters to do the work for us, to do the heavy lifting. Special characters, there's a variety of them in Linux. We're going to look at them throughout the semester. We're going to look at some of them today. And they're special because they do certain things, but they also do certain things in different contexts, so they don't necessarily act the same when we look at file name expansion versus regular expressions, which we're going to be learning about later, just as an example. So they allow the shell to match files that share particular characteristics in their name, and they help the user, they save a lot of time when issuing different commands. So to get the same output here, if you wanted simply every file with the extension .txt, you could issue the command ls star.txt. And that will give you every single file in the current directory that has a .txt extension, is a text file. So some common file name expansion symbols that we will end up using. Star or asterisk represents 0 or more characters. Question mark represents exactly one character, but any character. So it's like star, but also not, because it's slightly restricted to the number of characters. This means 0 or more of any character and any number of characters. You can also use a range of characters enclosed in square brackets, and that represents one character in that range of characters. So it's kind of like question mark with even further restrictions. And if you want to invert that, you could include an exclamation mark at the beginning of that inside the square brackets, and it will invert whatever the match is. So you use this for things like not numbers or not letters. So file name expansion file expansion is referred to as the process of globbing. And file globbing is a feature provided by Unix and Linux to represent multiple file names by using special characters, which are called special or wildcards. And we use these terms essentially interchangeably. So you can use these within single file names. Wildcards are symbols which may be substituted for one or more characters. So you can use these for generating the appropriate combination of file names depending on what we need in our whatever context we need. So how does this work? Well, we've got an example here. So we have a bunch of text files, all of the ones up there, plus there's a few other files in here. There's a .html, there's a .png. So when you issue the ls command, it's effectively working as if it has an asterisk immediately following. So ls star and ls do exactly the same thing. Ls space star, that is. They will search for all text files. Now we can add restrictions here, so ls star.txt, and that will search for all files in the current directory that end with the .txt extension, so anything followed by .txt. The shell then replaces this with every single one, and we get that in the output. You don't see it happen. It's opaque to us because this all happens behind the scenes in the shell. Instead, you get the output of the command. We could also issue ls question.txt, and that would give us file names with a single character .txt, and ls square brackets a to z.txt, and that would give us file names that only begin with a single a through z, or only contain a single a through z rather. So they wouldn't match, for example, abc.txt. They've just matched a, b, and c in this particular case. So let's have a peek at that in context, shall we? Let me switch back to my terminal. Make that full screen. So I'm in my directory here. I'm just going to create some files. We're using a single touch command, and then we can do a variety of different things on here. They're kind of meaningless file names. Just follow along. So I'm going to create abc.txt, 123.txt, abcd.txt. Generally, I would encourage you to use more descriptive file names. efg.txt, 321.txt, cde.txt. Sorry, not text, JPEG, JPG, and 576.mpeg, so MPEG. Now again, this is just making empty files. These aren't those actual files, but if we use the file command on them, we can see that they are not. They're all just empty files, regardless of the fact that they have the text extension. But the file extension is useful for what we're going to demonstrate. So I'm going to run a series of commands now. I'm going to clear that. We'll just do an ls, just to see what we got. So we see we have a variety of files here. Let's ls 3 question marks.txt. So this is going to be any file name that is any 3 characters followed by a .txt extension. So you see we didn't get 576.mpeg or cde.jpg, but we got all of these text files that were 3 characters in length. I'm going to hit up and do the same thing again, only with a 4th character, and we can see we get a 4th character. Now say, going back to that 3 character example, I wanted that, but I wanted only files that contain numbers, and entirely numbers. We have 3 numbers, 3 letters here. So I could do 0 to 9, square bracket 0 to 9, square bracket 0 to 9, 3 times. And you can mix and match these, of course. If we had 2 letters and then or 2 numbers and then a letter, you could substitute those in here. So there we go. And we see we only got those particular 3. We could also we can mix and match these as well, special symbols. So we could use 0 to 9 question mark. Well, we don't have any. That's a single character, do we? So we got no such file or directory. But what if we include 2 question marks? We get those as well. And if we want anything beginning with A to Z, we can do that. and there we have text files that begin with A to Z. We can also look for particular file extensions, which is more commonly how these tend to be used. Whoops, JPG. So ls star.mpeg will give us just our single mpeg, and ls star.txt will give us all of our text files. Now that in of its own can be useful if you're searching for how many of a particular file you have. But let's say we want to do something more complex. I'm just going to I'm not going to bother LSing again because we have it right here. But if we look at our file here, we got a bunch of our directory here. We got a bunch of files of mixed types, and it's getting kind of cluttered. Now we only have 7 files here, so it's not a big deal. But if we were to continue creating files in here in this manner, it would just be a mess. You wouldn't be able to sort things out. So we could use this to organize our directory into subdirectories and move the contents, which is a handy thing to do. So first we're going to deal with our pictures. So I'm going to create a directory called pictures, and then we're going to move star.jpg into pictures, and ls pictures to confirm that worked, and I'm going to do an ls of the actual directory at the end as well. Same thing with videos. We're going to make a directory called videos. We're going to move star.mpeg into videos, and ls on videos to confirm. And you may see when I type it, I don't get the slash. I'm using tab to autocomplete. That auto gives you the slash. You don't necessarily need it, but if you're using the autocomplete feature, that will do that. And finally, I'm going to move star.text into text. Oh, I got to make the text directory first. There we go. And do an ls on text to confirm. So there we go. I'm also going to do an ls on my current directory to confirm. So I took my my messy directory structure and I cleaned it up. I have particular directories here, and I'm actually just going to do an ls on all 3 of them that contain all 3 are organized in such a way that we contain our files are in appropriate directories, is what I'm trying to say. So we have a pictures directory that's going to have all our pictures. We have a text directory that's going to have all our text. And we have a videos directory that's going to have all of our videos. And a good sysadmin will likes a nice clean file structure. So let's remove some stuff using some file name expansion here, just to show you how that works. I'm going to remove all the text files. I could just rm, well, I'll show you in a second, this rm -rf text slash, and that would get rid of everything in there. But let's say we had some mixed files in there. I just want to remove the text files. I could rm text star.text, do an ls on text to confirm, and it got rid of all of our files. If I want to get rid of everything, I can do that too by including, very careful with this command when you're executing it, anytime you're executing this particular command, rm-rf star. This will remove recursively files, everything. If you execute this from your root directory on a system that you have administrative privileges on and you are root, it will wipe out your file system. You don't necessarily want to do that. I'm just cleaning my directory up for my next round of demo. So, back to the slides. We see everything's nice and clean. There you have it. For more practice, of course, well, the tutorial will give you that. Now, because these special characters, as we just learned and discussed, do special things in special contexts, so like star will give you anything, right? And question mark will give you any one per question mark of anything. sometimes we actually want to use just those particular symbols as they are, not as special symbols, just as they are. And this tends to come up more in scripting, which we're going to learn about much later in the semester, like week 10, I think, is somewhere around there, scripting. And of course, when we do regular expressions, in and around there too. So in the second half of the semester sometime, we're going to learn all about these. So because these special characters do things in certain contexts, there is, of course, a way, or a variety of ways, in Linux to tell the shell to ignore that special character and only use it as a regular text. So maybe you actually do want a question mark, because you're prompting a user for a question, and it makes sense. Or you're outputting a dollar value, and you want a dollar sign in front of it. There's 3 different methods of doing these to make the characters act like text. The special characters act like text, and it's referred to as quoting special characters. And you're going to want to use one of these in context, depending on what you're doing. And I'll show you what I mean by that shortly. So you can place a single backslash before a special character, and it will print out just that single character. So for example, echo, if you want an actual star, you will get that, \star. You can also contain the string, including your special characters, with single quotes, and this works for all special characters, as does the backslash. So this would print out just hello with a star on either side. Sometimes you don't want to do that, though, mainly with variables and shell scripting, which we're going to actually look at a little bit today, but we're technically learning that a little bit later in the course. So you can encapsulate your string in double quotes, and it will suppress all special characters except for variables, which are referenced with a dollar sign in front of them. Again, you're going to learn about those later in the course. But also, you should have learned about these in PRG 600. And let me know if you have when you come to our lab this week. If not, I will explain a little bit more roughly what variables do for this particular example here. Just let me get my command line up and running. So I'm going to use, I'm just going to clear my screen, the set command, which we haven't looked at. We will look at later. And all this does, whoops, is there's a special variable. Well, there's a variety of special variables, but there's a particular special variable we're dealing with here, $1, which is a positional parameter, and set just set that parameter to $1. We use these with shell scripts to pass them arguments, and again, we're going to look at those later in the semester. Just all you need to know right now is there's a special variable in the system called $1, and I just set its value to be OSL640. And we can see that by issuing the echo command $1, and it expands that to OSL640. But what happens if I do this? Well, I get a literal $1, right? What if I do this? Again, it's I get a literal $1. So both of these prevented bash from expanding this special character in context. But if I use double quotes, it doesn't prevent the special meaning of this $1, and we get the contents of our variable. Another way you can mix this up and look at it, so if we have, and you tend to use this a lot in scripting to display particular context, so we have, well, of course, it expanded our variable on both sides of this, so we got OSL640 is OSL640. But if I want to encapsulate that in single characters, all I get $1 is $1. Now maybe what I actually want in my message here is, and this is an example of where you want this, I want to tell the user or print out on the screen that the variable $1 is and contains the contents of the character. And you can do this, or contents of the variable rather. You could do this by combining some ways of quoting here. So within our double quotes, $1, note I have a backslash there, so I'm going to get a literal $1 is $1, and I get $1 is OSL640. Pretty neat. So like all of this, don't worry too much if you don't understand the variable bit, but do let me know in this week's class if you've learned that yet in PRG 600 and if you need further explanation. And for further practice on this, of course, look at this week's tutorial. And there's that assignment 1 bit in there again. I thought I got rid of all that. Investigation 2 and 3. And the practice questions 9 to 13. So it will all map to this segment. Thank you very much for watching. Good luck with all of your classes this week. And I will see you in our lab class. Take care. Be safe.